Hello and welcome to the AP Precalculus FRQ number 1. So this is the first year of AP Precalculus, so we don't have past exams tests, but this is one that is provided by AP themselves. So let's get right into it. Let f be an increasing function defined for x is greater or equal to 0. The table of values of f of x at selected values of x. So this is what this is up here. And the function g is given by g of x is equal to x cubed minus 14x minus 27 divided by x plus 2. Okay, first thing is a. The function h is defined by h of x is equal to g of f of x, which is equal to g of f of x. Find the value of h of 5 as a decimal approximation, or indicate that it is not defined. First things first, a graphing calculator is required for these questions, which makes our lives a lot easier. So first things first, we're going to write g of f of x, because that's what we're calculating. If we know that h of 5, which means that our x value is going to be 5, we can calculate this to be equal to g of f of 5, and from there, what's f of 5? We look to the table. Look, it's 34, so g of 34. And now we're going to take a step back and we're going to look at what g of x is. So g of x is going to be equal to x cubed minus 14x minus 27 divided by x plus 2. And when we have something, a value here, 34 of g, we're going to be basically plugging 34 in for every x value here. So let's plug that in. It would be easier to just plug this in on your calculator, but you can write it down on your piece of paper when you're taking the test. In your little boxes is what it's probably going to be if it's anything like the calc exams. But definitely write this into your calculator. If you calculate this by hand, either you're a genius or you would just wasted most of your time for this section of the test, and I don't recommend it. So plus 2, okay. And calculate this with your calculator. You're going to get h of 5 is about equal to, or we can just say equal to 1077.806. And that is your answer for A sub I. The second part of the question is asking us to find a value for f inverse of 4, or indicate that it's not defined. Basically, what that means is we're going to be looking at when f of x is 4, because if you remember, inverse just means you're basically swapping your x and your y. So look, when this is 4, when the function is equal to 4, then you swap it and you get that this is equal to 3. So we have f of 4, or f inverse of 4, is going to be equal to 3. You basically just need to remember what's what. What this is saying is that the y value, or the f of x value, is going to be in the inside rather than your x value. So don't get confused with this one. Remember, it's going to be this. It's not a normal function, it's the inverse function. Part B. Find all values of x as decimal approximations for which g of x is equal to 3, or indicate that there are no such values. So g of x is equal to 3 is equal to this whole mess here. So what we're going to do, we set 3 is equal to x cubed minus 14x minus 27 x plus 2. And basically what we want to do is we want to make it so that we don't have anything. So we have a graphing calculator first of all. So we're obviously going to use our graphing calculator. I'm not going to waste time and try and calculate this by hand. But the easiest thing to do is to make it equal to 0, because if it's equal to 3, unless you have a specific calculator that's good for that, it's a lot easier to calculate zeros. So what I'm going to do is I'm going to multiply x plus 2 on both sides, so that we can cancel this one out, and we have x plus 2. Again, this is in parentheses so that we distribute. So then we're going to have 3x plus 6 is equal to x cubed minus 14x minus 27. And we're basically going to just add back over, or subtract, I guess, really. So we have x cubed minus 17x minus 33 is equal to 0, which basically means now we can graph this as a normal function, and we solve for the 0 using our calculator. So you put graph, then you're going to solve for the 0 in your graphing calculator, and what you're going to get is x is equal to 4.875. Again, use your graphing calculator. There's no point in trying to solve this by hand. Okay, so in the second part of B, we are asked to determine the end behavior of G as x decreases without bound. Express your answer using the mathematical notation of a limit. So if you don't know what a limit is, crash course, you have a limit, and it's asking us as it goes, as it decreases without bound. So as x decreases without bound, that's basically saying negative infinity of our function. So of course it's actually not going to be f of x in this case, but in general notation we're going to write f of x. So that's your limit for you. I guess we could write n here if we really wanted to be official for or general, I guess I should say. Okay, so we're going to express it for g of x. So we're going to say same thing. We're going to say the limit as x approaches negative infinity of g of x, which we might as well just plug in here, minus 14x 27, and then we have divided by x plus 2. Okay, so now we're finding the limit of this. I think the easiest way is to look at the highest power on either. So we look, this is to the power of 3, this is to the power of 1. We see that this is going to be some infinity. Whether it's positive or negative, we don't know yet. However, what we're going to then look at is we're going to be dividing these, and if we have a negative, because it's to the power of 3, so if we look at, let's give an example. Negative 2 to the power of 3 is not going to be 8, it's going to be negative 8. And negative 2 to the power of 1 is going to be negative 2. So the negatives will always cancel out in this case. So this is going to be getting larger at a much faster rate than the bottom, which basically means that the limit of x as it approaches negative infinity of g of x is going to be infinity. Again, because these are odd powers, the negatives stay in both of them, the negatives will cancel out, and the top is much greater and will be increasing at a greater rate as you approach infinity. In part C, we are going to be using the table of values of f of x to determine if f is best modeled by a linear, quadratic, exponential, or logarithmic function. My favorite way to do these even though we know that the part 2 is going to make us look at the numbers specifically and the changes in output, is to look at a graph. So it's pretty easy to graph some of these values out. Look, we're going to be going between -10 and 34. So when it's 1, it's going to be -10. So we'll go like a third-ish of the way down. When it's 2, it's going to be -5. So we split the difference here. When it's 3, it's going to be about 4. Say it's about there. When it's 4, it's going to be 17. Okay, a little bit past halfway, like right there-ish. We'll extend that up. And when it's 5, it's going to be 34. So this distance here. And to me, I can already see the shape kind of coming through. If we look at the line of best fit, that's not linear. That's not gonna be exponential either. It's not increasing like that. It's increasing most like a parabola, so a quadratic function. So I'm going to prove it with numbers as well. So we use the table of values and we can say quadratic, and we're going to prove it. So what you need to remember for this is second differences, which is basically a fancy way of saying if the differences between these values and then the differences between those values are equal to each other, then it's most likely going to be, or it's going to be a quadratic relationship. So we can see the difference between this first one is going to be 5. The difference between this one is going to be 5 plus 4, 9. The difference between this value and this value here is going to be 13. And the difference between these two values is going to be 17. And now we take the difference between these two values and this value and this value and these values, and basically what we're doing is we're saying that if this second difference is the same, then it will be a quadratic function. It's true for quadratic functions. So we take this and we get 4, and what? We get 4. Look, the second differences are all the same. This is just something you need to know for this course. And give our reason. So we said it's quadratic. We can say second differences are the same. I'll just write that. However, we need to prove it more than that. Second differences are the same, and the increments between x are also the same. It's not like we're going and increasing by 10. And the increments, I'll just write that, between x are increasing are the same. And consecutively increasing. It's a lot to write with your mouse. Okay. And there we have it. That's part C. So thank you guys for watching the video. Make sure to like and subscribe if you want to see more. Yep, and I'll do more of these reviews for AP Precalc since I got lots of notes to do on my poll. Thank you.